You know, I feel it's very you had auspicious beginnings by starting, you know, in your PhD. You went to, I think, Fry's or something, bought a bunch of x86 boxes
It's
with a
true. Yeah.
4-port NIC,
Yeah.
and you kind of duct tape it under people's desks in Stanford, and that
Yes.
was
True
basically
story.
your switch for each, and then you
That's true. Yeah.
installed some PhD level software on each of those, and then went
Yeah.
and did some stuff
Yeah.
that led
Yeah.
to the creation of what we'll talk about soon, which was
Yeah.
software-defined networking and
Yeah.
open flow. But
But
that hustle as a PhD student, you were
yeah.
actually being an entrepreneur. Uh,
Yeah, well, that's funny. Well, yeah, this is a true story, right? There's kind of two computer scientists. There's like the theory, algorithmic folks, and you know, listen, that wasn't me. And there's the systems folks that builds things, and I've always been more of kind of like the the systems. You know, when I joined Stanford, like networking was like the internet. You know, that's what like, but that's what you study. You study the internet and you study protocols in the internet, and like nobody thought about enterprise networking, which to me I thought was ridiculous. Like, I mean, like, you know, everybody was like, you know, I mean, like so much of the research and everything else was like, you know, like how do you scale the internet? Of course, the internet was an enormous success, and like, and they. Uh, from many reasons, from technical, from economic, from business, so that was the core focus. But if you actually looked at like the number of ports being sold, like actual networking ports, like they were all in the enterprise, and there's very, very little academic focus on it. Almost none, almost zero. I mean, when I joined PhD was in 2003. I mean, it was just such a backwater. But I thought that's where all the interesting problems are. I mean, if you look at what are the problems on the internet, the problems on the internet is like, okay, get a packet between point A and point B, you know, in the best way possible. It was kind of best. And that created basically so much of the discipline of networking. Whereas if you looked in the enterprise, it was like, you know, security, policy, mobility, like there's all these interesting business logic, like whatever. And so, you know, and what had happened at the time is, you know, so much of the internet architecture had been kind of put into the enterprise, and it just wasn't appropriate. I mean, the internet wasn't meant to be programmed. Like that architecture was just never meant to have these constrictions. And so then the question is okay, like, okay, if we're going to like create a new type of network for the enterprise, like for the campus, what will those technologies look like? And you couldn't take existing networking chips. Like networking chips basically just look up packet headers and forward them. And so, so we're like, well, why don't we just kind of start with like a programming model? So you're right. We actually went to Fry's and we'd have carts of these kind of the cheapest servers we can buy, and we'd throw NICs in them, and we'd kind of program kind of what we were doing. And that was like the precursor to OpenFlow, because, and then, you know, so basically the original research, which was a project called SANE, required an x86. And we required that. And then we're like, okay, how can we make this so we can work with actual switching hardware? Because you need it for port density. You need it to like, you know, do networking at scale in high performance. And that's kind of what became Ethane, which became OpenFlow. So yeah. But
and we,
anyway, I'm not sure how entrepreneurial that was, but it was definitely like kind of like the systems approach to this stuff.
uh, in my book, I think it's pretty. In India, they say "jugadu." You know, you're just gonna get shit done,
I love it.
and I think there was an element of that.
I mean, I was legitimately enthusiastic about software-defined networking and what we were doing every year of those 11 years we were doing it, like legitimately. But it wasn't because of the tech. And it wasn't because of, you know, whatever, disrupting of a big business or whatever. It was like the way that all of these things came together. There was this almost this kind of grand unified reckoning, you know, that was, you know, it's almost like you kind of see this future and you see how it's interconnected, and you see the implications and you see the shift, and you've got a group of people that see it as well. And then, you know, it's very exciting to talk about. And so I do think in that case, there's genuine enthusiasm and excitement about the space from that. And so while we were getting near the end of the PhD, of my PhD, you know, it had become a pretty kind of, there's a lot of buzz around this, and there's a lot of interest and a lot of follow-on papers. And so we'd gotten approached by the government, who's actually quite interested in us continuing the work, right? It was actually the intelligence community. And so they offered to give us, you know, some money to do it. And so it was interesting. So we decided to create a company, you know, and it wasn't really clear at that time, you know, what the end state of the company was. We just knew that, you know, there was a new way to build networking and there was a number of problems that we could tackle. And so, you know, in retrospect, we probably should have spent more time at Stanford kind of really thinking about the specific problem to solve. But instead we're like, listen, we've got this kind of interesting technology. And so, you know, I basically went from my defense after I defended to the lawyer's office to incorporate the company. We incorporated the company